meters have got such kind electronics workbench. Therefore, in our country, this one. Other country maybe other design. But one common thing is any sensor should be the electric installation should be highly safety. This material is digital oscilloscope. When we are unpacking this instrument from cardboard, you do have to get a power cord, and the next one is you should have get the probe, and the next one you should have get a start quick or quick start manual, and then the manual of the probe, and then USB cable. You have to get all these accessories. Therefore, unpacking procedure is like this one. This is digital oscilloscope. An oscilloscope is an item of electronics test equipment that enables a waveform to be seen, and in this way makes it very much easier to see any problems occurring in an electronic circuit. There are two types of oscilloscope. One is analog oscilloscope, the other one is digital oscilloscope, and this one is digital oscilloscope. It has two main purposes. One is displaying any wave shape or waveform which is produced at test point of an electronic circuit, and the other one is measures the parameter of the wave shape or waveform which is displayed. Second one is inspection. We do have two inspection at here. One is power inspection, the other one is function inspection. The first one is power inspection procedure. How it is? First check the nameplate or the rate of the instrument, and the instrument says 100 voltage to up to 240 volts at 50 or 60 hertz. Therefore, this our power line is 50 hertz, 220. Therefore, no more difficulty, and then plug the power cable like this way, and then make it the leg of the instrument like this way, and prepare and position the instrument like this way. It is easy to get information from the instrument for the student like this way. The next one is the power plug is 3 terminals. In our standard, in our country, it is 2 plug, 2 pin. Therefore, you have to connect 3 terminals to 2 terminals converter circuit like this way. Therefore, and your workbench has got a socket outlet. Then give a power. Now power cable is connecting with this procedure. Therefore, this is the first procedure for the power inspection. The second one is get a power button on the front of the instrument. This one is a power button, and press. when you are pressing this one, the logo of the material is appearing at the display board or at the display LCD, and the other function key is getting lighting backlights, and we do have got a sound beeping. We have got a sound. Therefore, these three things should be appearing when you are getting push of the power button. The first one is logo, the second one is function, backlight, the third one is hearing a sound, the relay sound. This one is indicating the power supply inspection is perfect. The second one is a function inspection. To inspect this function inspection, we do have three procedures. This one is a probe cable. This one is a probe cable. This one is connected. It has a groove, up and lower groove. And by aligning this groove with the pin of the X channel, this instrument have two channels. Therefore, connects the probe on this way, groove and pin, and then turn on to the right. And then, if these you are pulling, nothing. Therefore, connection is like this way. And with the same fashion, connect channel B, channel Y. With the same fashion, you are connecting and then turn on in the right. Therefore, this is connecting the probe. Now the probe have two terminals. This one is a hot line and this one is a ground line. Now connect the hot line on the pulse terminal compensation. This one is a compensation terminal like this way, and the other one is like this way. Now the second step is push the default, then auto setup. Wait until some minutes, and then you do have such kind wave shape. If it is according to the manual, page 5, there are three graphs. The first one is undercompensated, the second one is compensated correctly, and then overcompensated. Now, when you are finishing these connection procedures, the signal displaying on the display, the signal when the wave shape should be perfect, pulsating, perfect. If not, make compensation by there is non-metallic screwdriver, and then there is a screw on the probe, and then by this one you can make it. You can make it turn on to the left or the right, clockwise or anti-clockwise. The graph is appearing, the middle graph perfectly. Now the graph is getting perfect. You can make this one, and now this is a perfect pulsating you have got. Now the compensation is completed. The other point is a front panel and the back panel. The front panel, there is a push button. This one is vertical zone. This one is horizontal zone. This one is a trigger zone. Therefore, to make the division scale up, you can 100 millivolt per division, 200 millivolt per division, 500 millivolt per division. Therefore, this one making clockwise and anti-clockwise, you are adjusting or scaling the division with millivolt. And this is, you make it up and down movement of the wave shape. This one is up and down movement of the wave shape. And this one is making or calibrating the horizontal x or the x-axis or the time base from second up to nanosecond. Therefore, when you are moving or when you are rotating this one, revolving this one, you make it 1 millisecond. When you are moving this one is clockwise, 5 microsecond. Therefore, there is a direction, arrow direction, follows that one. If you want to scale up the time base in second, you have to move anti-clockwise. If you need the time base or scaling in the time in the nanosecond, you have to move in the clockwise. This is how to use this digital. Now, by now, the digital oscilloscope is ready to function. This one is digital lab trainer. As the name indicated, it is able to students perform basic digital lab experiments by one, like basic digital logic gate circuit and gate or gate, two-digit 7-segment display experiment, and so on, without need of discrete components since it is built-in. The trainer has fixed power supply, variable power supply, two-digit 7-segment display, function generator, digital voltmeter, 8 buffer LED display, 8 data switch, 2 function switch, 2 pulse switch. All are found by one and are the basic requirement to perform the basic digital lab experiment. So the student no need of discrete component to perform the experiment. And when unpacking this one from cardboard, you have to get this power supply, this extension pin, this manual, and this solderless breadboard. This one is almost all. This one is DC power supply. The output is DC power supply, positive this one, negative this one. Then connect any measurable voltage, connect the positive this one and the positive. The other point is there is 2 7-segment display. Therefore, you can make experiment on 7-segment display. There is decoder, there is driver. By selecting the digital logic 1, logic 2, logic 0 or logic 1, you can make a decimal display. That means there is a decoder, logic or binary converter, binary to decimal converter at here. You can arrange it. The other point is 8-bit data switch. There is 8-bit display. 8-bit display. By making this one 0 or 1, 0 or 1, you can display at here. There is a pulse switch generator at here. Pulse generator, there is positive and negative fixed voltage, and there is a variable 50 voltage, 50 plus 50 voltage, and negative field voltage. There is a pin and you can variable, and there is a variable 5 volt voltage, and there is a fixed 5 volt voltage. All this one is about ideal digital lab. Now the next one is power inspection. This device or this instrument has 2 power supply options, 115 voltage and 50 Hz, 230 voltage system. Now check and verify your power supply line in your country. Therefore, in our country, the power supply is 50 Hz, 220 voltage. Therefore, there is a selection switch at here. Then this tip switch is option has two options. One is 230 voltage, the other one is 105 voltage. Therefore, the first one is check and select your proper power supply voltage. Now we select 230, and the other one is there is a fuse at here. If anything is happened, the fuse is protecting this equipment. Therefore, to dismantle the fuse, turn on this one in anti-clockwise, and now you are remove out the damaged fuse, and then this one is unplug from the socket and change the new one and plug on the holder. This one is a fuse holder. Rotate this one anti-clockwise in the reverse direction. When dismantled, the direction of when you are putting the fuse in the opposite direction. Now we are arranging the switch, deep switch, and then connect on the socket outlet on the page. Now make it on the power supply at here, and then you can display or you can get such kind display. This is the power inspection. Material has different parts, and this one is a function generator. We do have three types of wave function can produce or can give out. This one is waveform selector probe. You can select sinusoidal, sawtooth, and pulsating. This one is range selector, frequency range selector. You can select different frequency range, and this one is adjustable frequency. Adjust frequency. Your signal at how much frequency you require. Therefore, this one is, and the amplitude of the signal what you need, because when you are producing a wave shape or signal, how much the frequency and how much the amplitude, and then according to that one you can adjust. There is a universal counter at here, frequency counter and time counter, and there is a digital voltmeter, and the digital voltmeter has a range selector, 2 volts, 200 millivolts, 20 millivolts, up to 200 volts. You can select. Therefore, this voltmeter can measure up to 200 voltage DC voltmeter. This one is almost all. This one is DC power supply. The output is DC power supply, positive this one, negative this one. Then connect any measurable voltage, connect the positive this one and the positive. The other point is there is 2 7-segment display. Therefore, you can make experiment on 7-segment display. There is decoder, there is driver. By selecting the digital logic 1, logic 2, logic 0 or logic 1, you can make a decimal display. That means there is a decoder, logic or binary converter, binary to decimal converter at here. You can arrange it. The other point is 8-bit data switch. There is 8-bit display. 8-bit display. By making this one 0 or 1, 0 or 1, you can display at here. There is a pulse switch generator at here. Pulse generator. There is positive and negative fixed voltage, and there is a variable 50 voltage, 50 plus 50 voltage, and negative field voltage. There is a pin, and you can variable, and there is a variable 5 volt voltage, and there is a fixed 5 volt voltage. All this one is about ideal digital lab. This is a programmable DC power supply. It is convenient, flexible, and multifunction. It is designed with 3 groups of independent output terminals. The output voltage of 2 groups is adjustable and another group is fixed to select 2.5 volt, 3.3 volt, and 5 volt. The instrument also provides output short circuit and overload protection. As usual, when you are installing this instrument or this power supply, the first one is power inspection, and the power inspection starts from the nameplate. Therefore, this power supply has 4 level voltage supply: 100 voltage, 120 voltage, 220 voltage, and 230 voltage have available. Therefore, according to your power line, you have to adjust the 2 switch, the lower one and the upper one switch. Therefore, according to our line, voltage is 220 voltage. Therefore, the position of the switch is, both of them are at the left. Therefore, by putting or pushing the switch to the left, and this one is to the left. Now, you are selecting your compatible voltage from the power supply. Now, the second one is connecting the power plug. Before that, the fuse are at here. It is fuse protected socket. Therefore, the fuse is at getting this one and by making this one. And this is a power supply and connecting the out source. This connect in the outlet socket on the page. Now, this one is a connection of a power supply. The second one is power inspection. When we are pushing the power button in the front on at this button, the backlight of the function key is, backlight is elite or bright, and the display is displaying channel 1 voltage ampere, channel 2 voltage and ampere. By now, the function is working perfectly. The power supply has 3 channels: channel 1 negative positive, channel 2 negative positive, and channel 3 negative positive. And this one is common ground for channel 1 and channel 2. And the operation mode of this one is independent, series, and parallel. Independent means channel 1, channel 2, channel 3 are supplying independently. They don't have any common interest or common connection. In series configuring, channel 1 and channel 2 are connected in series. And then it giving 64 voltage and 3.2 amperes. And the load is connecting channel 1 negative, channel 2 positive. The load is connected. Now, and when it is a parallel, channel 1 and channel 2 making a parallel, the power supply is giving 32 voltage and 6 amperes. This one is parallel configuration. Now we do have 3 configuration independently. If you want to operate, this one is independent configuration or independent mode. No more touching series and parallel without any touch. Therefore, only on select channel 1 and turn on channel 2. This is channel selector button. This one is make on off that channel. This one is channel 2 selector, make on off the channel 2. This one is channel 3 selector and make on off the channel 3. This one is turn on and off button. This one is selector. This one is make all on off. You can off or you can off and on. Now the voltage is at here independently. Now voltage is Now there is a knob at here. There is a voltage and ammeter selector. There is a fan. Therefore, to adjust the voltage, that means what you need the voltage, how much voltage you need at here. Channel 1 independently. Now select channel 1, adjust the voltage. Now channel 1 is by now is giving 2.9 voltage, and adjust the current, how much current it is supplying. For instance, this one is 2.1 amperes can supply. This is independently without any channel 2. Therefore, independently you can adjust this one. Now make it on. The indicating light this one is giving when it is bright in green LED, it is working in CV, common voltage state. When CC, it is giving red ampere, it gives common current voltage. By the same fashion, channel 2 is, you can adjust. Channel 3 is not adjustable, it is selector. There is deep switch selector. 2.5, 2.2, 5 volts. Maximum current is 3. You can, if you want to use the channel 3, and how much the voltage maximum volts? 5 volt, maximum current 3.2. Therefore, you are selecting by deep switch. This one is independent configuration. And the second one is series configuration. If you are making this button is series, you can adjust the voltage. In series means the load is connecting negative terminal to channel 1 and positive terminal to channel 2. The load is connected, and when this channel is connected in series, it gives 64 voltage, 3 amperes. Therefore, you can adjust the same one, select the voltage. Voltage is increasing. Therefore, the 2 is giving 64, and always series is the master one is controlled, the slave one. This one is a master, this one is a slave. Therefore, adjusting the master, that means in other words, adjusting the slave one. Therefore, always when you are connecting series, turn on, select channel 1 and turn on channel 1. Now adjusting the voltage, push this one the voltage and adjust how much you need the voltage. Therefore, at this terminal, you get 10 voltage, and the ampere is, when it is ampere, 2 amperes at here, 2 amperes. Amperes. The next one is adjusting in parallel. In parallel, you are making this channel 1 and channel 2 in parallel. Therefore, the master, where it is the load is connected, the negative terminal of channel 1 and positive terminal of channel 2. And then select channel 1 and turn on channel 1, because we are connecting in parallel. Therefore, now the voltage is adjusted. When you are connecting channel 1 and channel 2, it gives you 32 voltage and 6 ampere. 6 ampere. Now, therefore, in parallel mode, CV, the channel 1 is working in CV and channel 2 is working in CC. This is the red light, All this one is summarizing and comfortable. Lesson is how to install, configure, and how to use this electrical equipment which is found on the workbench of electronics lab workbench. This one is function or arbitrary waveform generator, which is generate 5 standard waveforms, that is sine wave, square wave, ramp wave, pulse wave, and noise wave. As you know, any waveform has its own parameters, so this function waveform generator has capable of to adjust the parameter of the corresponding waveform or the selected waveform. Example, the circuit designer needs sine waveform to operate his circuits. At what frequency, amplitude, and phase angle the sine wave should be. So first he or she selects sine wave and adjusts frequency, amplitude, and phase angle and supply to the circuit. The function is producing or giving different wave shape of electrical signal. So the first one is to install this electrical equipment or function generator, adjusting the leg, which is make proper to vision for the operator. Then to adjust that one, this point and this point pulling outside. Therefore, the leg or the support have got a free movement. Therefore, as you like, you can adjust the leg, and then at the end, when you are getting the proper position, pushing on the opposite direction, inside. The first one outside and then inside. Any electrical equipment, the first inspection is a power inspection, because you have to check the line which you are going to use in your workbench, and the required voltage line for the machine should be compatible. Therefore, to do that one, we are checking the power supply. That means the line voltage should be, therefore, at here 110 to 140 volts at 50 or 60 Hz. Therefore, in our line, in our country or in our line, 220 and 50 Hz. Therefore, it is compatible. Connect or plug the workbench socket outlets. Now you are checking. Then at the first, making a power on, which is a power push a power button. Therefore, when the power is on, the logo and the backlight of the function key is bright. This indicating the machine or the equipment is very well healthy, in healthy conditions. And then this sine wave is immediately by default, the machine is this one. Now this is a power inspection. Now the machine or the equipment is ready to use. Therefore, the use of this machine or this equipment is producing and delivering different type of wave shape of electrical signal, like sine wave, square wave, ramp wave, pulse wave, noise, arbitrary. And there is a key, numeric key at here. Therefore, to set a parameter, you can use by this one or by knobing. Clockwise is decreasing, anti-clockwise is decreasing, clockwise is increasing. This one. Therefore, the other point is, from the carrier sine wave, you can move, you can produce different kind of mood that's modulated. Modulated signal will be producing sweeping. You can sweep. That means starting frequency to stop frequency adjust by how much time, span time. Therefore, you can produce that one. Limited signal, infinite not. Limited signal, burst is number of cycles, because the wave shape has cycles, and so you can use it this one. And here it is selecting the push button under the sine wave. Under the sine wave, any wave shape of signal, electrical signal, has its own parameter. With that parameter, you can describe that sine wave. The sine wave should be parameterized. That is frequency, how much frequency of the signal, how much amplitude, how much peak to peak, how much period, how much offset, and the phase angle. These all are parameterizing the sine wave. Therefore, every sine wave or every function wave shape has its own parameter. And then the next, that one is different parameterized at here. And then by selecting, pushing this one, amplitude, offset or low value, phase, and so on. Therefore, when we are pushing this phase, the phase segment at the display is highlighted. This one is highlighted. Therefore, by numerical or by knob, you can adjust, or you can move and up by the arrow. Therefore, selecting the parameter to be going to calibrated or to be going to setting, you can use by up and down arrow, and or by pushing on this button. This one is back. If you are moving at here, if you want to back, and the other point is all about the front panel of the instrument is like. Therefore, how to use the function or the key. Therefore, the first one is the circuit designer, he needs what type of wave shape first. Therefore, you can select, first step, you can select what you need, what kind of wave shape you need. Therefore, there are different square wave, pulse, ramp, noise, or arbitrary. Therefore, selecting. Then the next one is you select the wave, like for instance is a sender, you select a wave, and then you have to set a parameter. The parameter which is for this sine wave, the frequency, how much frequency, how much amplitude, how much offset, how much phase angle. Therefore, the first one is frequency. As you know, you can change the value of the frequency by making clockwise is increasing, anti-clockwise is decreasing. Therefore, any sine wave at here producing the minimum is 1 kilohertz. 1 kilohertz. Therefore, you can set the frequency when you are amplitude by this one or by making the arrow amplitude. Then for the amplitude is when you are selecting the amplitude segment of the display is highlighted. Therefore, it means that that parameter is selected and select and move and change the wave and so on. And the other one is offset. And then offset, how much DC value of offset is checking. And then the other one is pushing pulse, phase, how much degree. And then you are changing peak to peak, frequency, and phase angle and offset. By this kind, in this way, in this procedure, you can set the parameter what you are select, the wave shape what you have select. This is it, all about. And then the selected and the setting sign, the setting wave shape is outputs should be delivered to the external circuit by a probe. This probe is giving that here, and then connect, and then the power supply will be giving to the circuit. This one is negative, this one is hotline and supply. Therefore, by this way you can use it. This is all about signal generator. Now the next one is a measurement at here, LCR meter, which is measuring the passive component, L inductor, C capacitor, R resistance. You can measure inductor, capacitor, resistance, this one. And then when we are unpacking this instrument from the carton port, you have to get this is RA2 USB or optical interface, and this one is a CD, and this one is a manual you have to get, and then uncover this one, and replace or putting the power, the 9-volt battery at here by making this one, and puts 9-volt battery at here. Now, by now it is ready, therefore you have to put the red one at the red plug, the black one at minus. Now make it the leg or the supporting this one, and then when we are making this one, the display is getting or displaying in that way. Therefore it is indicating the meter or the instrument is very healthy. Now there are different keys, functional keys at here. This is a frequency key. The frequency key is measuring two types, that is 120 Hz and 1 kilohertz for measuring a capacitor. And the other one is parallel and series. This parallel and series is selecting the mode. In parallel mode or in series mode, you are going to measure the circuit impedance. And the other one is, there are two types of display at here. LCR display, this one, and this one is QD. Two types display at here. This one is LCR display. This is QD R display. For this class, we are going to use LCR display, and this one is LCR display. The function is selecting what kind of component or circuit you are going to measure. Inductor, capacitor or resistance. This one is selecting range. If it is in resistance, it's selecting in kilo ohms, mega ohms, in ohms, selecting range. And this one is minimum and maximum. Of course, we don't that much is not necessary for this. And then now by making this one is, when you are pushing this one, you are selecting resistance, and then it is auto selecting the range. Here it is auto ranging. By itself it is ranging. When we are putting the component at here, it is searching the range, in which range that component should be measured. Therefore this one is all manually, and then this is, and then when we are pushing this one, it is going to millihenry, Henry and microhenry. This is H at here, this H, and this is at frequency. And then when we are putting this one in kilo resistance, therefore by clicking this one or by pushing this key button, which is LCR, and then putting that one, and then when we are putting, this is electrolytic capacitor. The frequency selecting is for the capacitors ranging. Therefore, if the capacitor is electrolytic, most of the time select 120 ohms. And for the others, it is selecting 1 kilohertz. This one 120 hertz. Therefore, this is a capacitor, which is electrolytic capacitor, and the long one, the long lead is positive, and the shortest lead is negative. And then putting this one is the largest or the long leg is putting at here, and the negative at here, and selecting it is range auto now by this one 101.49 microfarad. If you are changing the frequency, it is reading is less. It's not reading exact value. Therefore, always electrolytic capacitor should be measured the frequency at 120 Hz. For the others component, it is 1 kilo ohms, 1 kilo hertz, 1 kilo hertz. And this is about LCR meter. The next lesson is about a soldering station. One workbench should have a station for soldering for the student to be set up or prototype, and then they are going to build their circuit on the breadboard. Therefore, they make the component put at here, the circuit, and then they make is fixing the component on the board, that is soldering technique. Therefore, one area or this workbench should be get its own station for such kind process. Once the students have checking their circuits working or not, and then verifying, and then it is working well on the LCD or on the ideal and different method, then they are fixing or building the circuit on the board. And for that purpose, there is a soldering station. This is a soldering station. When the operator or the instructor or who are installing this machine on this workbench, first unpacking, and when he are unpacking, he should get different accessories. He should get the power cable, power cord, and this one is with sponge the base of the iron, and this one is the house of the iron. When getting this one is putting this iron on this one because for safety, and then due to some reason he may touch the hot part of the iron that make accident. Safety first for yourself and your component. And then this is iron, the iron one. Now the next one, once you have checking all this one is found in the cardboard, the next one is power inspection. As usual, power inspection, and the power inspection has got always on the nameplate somewhere in the instrument. For this iron station, there is 120 volts, 60 Hz, and up to 85 watts. If you are above this one will be burnout. And then the power supply for this one, it should be compatible to our power line, and then our power line is 50 Hz, 120. Therefore, we need another power supply, a transformer at here. This transformer is step down the voltage 220 to 120 and converting the frequency. This transformer has two purposes: step down the voltage to 105 and converting the frequency from 50 Hz to 60 Hz. Therefore, the transformer part is this one, and this one is the input 220 voltage, which is going to be plugged in the socket outlet of the bench, on the bench, and this one is the output is 105 and 50 Hz and 50 Hz. Now this one is workbench plug, and this one is connecting the power, and this one is like this way. Your power line or the power cord is connected. And then the other thing is you are putting or fixing this holder, the iron solder or the iron holder on this one by pushing. It needs some force, and then connects. There is a groove at here. There is a groove at here, and then coincide the groove part of this one point, and then pushing. And also there is arrow indicator in which direction you are connect. The iron, soldering iron is connected to the controller, and the iron is putting like this way. Once arranging all this station you are producing, and then bring third down the tool, which is magnifier and holder, the circuit board holder, you have to put that here. It has also another circuit board. Therefore, if you don't want to use this one, you can put this one is like here, like here, like here, like here. You can use alternatively, but for now, then you are arranging and assembling the workstation of the soldering iron like this one, and then as usual you have to convert the terminal to 2 terminals, and then plug in the outlet socket. Now in the front of the controller there is a switch, and this one is all about the display. Therefore, to increase or decrease the amount of adjusting, decreasing, increasing the amount of temperature. Your temperature is reading in Fahrenheit, and then increasing. If you are increasing the value of the temperature, there is indicating at here dangerous. It gives you information you are setting the temperature in dangerous zone. You see the point, that one is indicating you are in dangerous. Therefore you have to decrease. When such kind of symbol are getting at here, which is dangerous symbol, you have to decrease. You have to decrease. Now that point or that symbol is disappear. It takes some time to get the setting point, and the other point is within 2 minutes. 2 minutes. Therefore, by arranging the time, in second, and getting up and down voltage, once that temperature has got the iron has got that temperature, this one will be going to off by itself. Like this way, you can set up your soldering, and then by holding this one, by using this one, some small component or some small thing like this way, you are using soldering. And the other component or the other material is desoldering. This is one of the other. In the soldering station should be gates on this one, should be. Therefore this one is a soldering pneumatic system, desoldering or sucking the solder. If you are making wrong soldering on this component, by using this one and then keep it that here, and then by making some melting at here, and then when we are getting molten, this one will be sucking by using solder. Now the last step is how to manage the component, discrete component in the component box. Therefore, this component box has 20 drawer, and each component box can be making a divide, 2 box, 3 box, and so there is a divider or make a partition, and then by putting this one you can partition each drawer in different numbers. For instance, I make this drawer 2 locations, and then the next one is how to install, how to install the box. How to install the box? One is there is a hole at here. There is a hole. By fixing some hole, if you want to fix or to mount this component box in the wall, make a hole in the wall and then by screw and nut you can fix it. Or by using this foot leg, by using each component box has touch kind accessories, and then this one is putting this one is putting this one and then putting around the table. Therefore, the location of this box always is the nearest to the instructor, because to manage and to secure the component available at here. And the second one is labeling the box and the drawer. By any mechanism, any instructor should labeling the box number of the box, and then the other is labeling is the drawer number of the drawer. He can assign drawer number of box 01, drawer 01, and front back, like this way, and then this one is a front, this one is a back. Therefore, he make a partition. Some component came with a sticker, their own sticker, and the sticker is there is a series. Therefore, for instance, this component filling or this component package, different ICs 74LS00 series integrated circuits. Therefore, different part number has there in this. Therefore, for each filling or for each case, their own the same part number are found in the IC, the same part number. Therefore, by bringing this one and then bring out from the case and then read the part number of this one, and for instance, this part number is 74LS00, and then where you are putting in front. Therefore, about this component, exact specific location has got from the box. In which number of box 01, in which drawer 01, in which partition, front or back. Then this one is, for instance, it is found in the front, therefore it is front. Immediately bring out and then pick the required component. By this way, arranging each discrete component in the box. And the function of this procedure is to manage the components, properly, to use it, and then also how much this component is remaining, how much it is used. This kind of auditing system, it is better. Therefore, he make a list, the list of the component is, for instance, the list name is 74LS00 series integrated, the list name, and the list name has tables, number 1, part number, and then in which location. The location has three information: number of the box, number of the drawer, and front or back. All this one is be listed, and according to that list, he distribute the component. Our lesson is finalized at here. Let us summarize what we are done in this electronics lab, from installing to calibrating and arrangement of discrete components. Therefore, on this lesson, we have seen how to arranging or layout electronics lab according to the design of or the volume of the room, and then we are selecting or organizing which basic electronic component which is organizing, which should be found on the workbench. We are selecting, and then we are organizing the workbench with different electronics equipment, and then like this way, what look like leak. And then the last one is for each major components, how to install, how to powering, and how to calibrate, and how to use it. We have seen in this class, and how to use it in this class. And the last one is we have seen how to manage the discrete components, how to manage a component, how to locate in the and driving or setup or preparing the location and distributing in the component box each discrete component like this way, and organizing the lab looks like this one. It is very interactive, and then so any student or any instructor have seen this video or this video lesson, he can organize, he can arrangement, he can design his own lab, or also his own lab, personal lab, or in any education class he can design and set up the electronics laboratory. I hope this one is a supportive video, and any question and any comment I can take from any direction, from any corner. This is all about. Thanks for the lesson.